Question number 2a part, longitudinal wave. If a direction of propagation of wave is along x-axis, if disturbance moves along x-axis, particle number 1, if its oscillation is also along this line, along x-axis like this. So, if the oscillation of the particle is along the same line in which the wave travels, is termed as longitudinal wave. So, particles oscillate parallel to propagation of a wave. Wave travels along x-axis, particles also oscillate along x-axis. What was the transverse wave? The wave travels along x-axis, particle oscillate along y-axis. In a transverse wave, the angle was 90 degree, and here it is parallel to the same. 1 minute with you to write. What is a longitudinal wave? 1 mark question, 2 lines. What is a longitudinal wave? Longitudinal wave motion is that wave motion in which individual particles of the medium execute SHM about their mean position along the same direction along which the wave is propagated. So, wave propagates along x-axis, particles also execute simple harmonic motion along x-axis. Sound is one of the examples. So, explanation for the same. As an example, there is a source, so it is a pipe. There is a pipe, and for this pipe, you have a source of sound. This is source of sound. So, you have a source of sound at this point, and there is a listener to the other side. On this end, there is ear. So, sound, there is a source. How this sound travels from source to the listener. On this end, you have ear. How sound travels from one to the other? 1. If there is no medium in between, if it is vacuum, do you think this sound will travel from S to E? Because sound is a mechanical longitudinal wave. It needs a material medium to travel from one point to the other. How it travels is, suppose there is a molecule or point 1, as this source creates a disturbance, this particle number 1, oscillates about its mean position along x-axis like this. When it oscillates, it gives information to the next one, causes oscillation of second one also. This gives information to the next, particle number 3, again it oscillates. Particle number 3 gives oscillation to particle number 4 and to say particle number 5, and this causes variation of pressure on the eardrum. Variation of pressure. That pressure variation is transferred to brain, which we take it as sound. This is how information or source S. This is how sound travels from S to E. Wave travels from S to E along x-axis through oscillations of particle number 1, 2, 3, 4 and 5. Source S causes disturbance of particle number 1, and particle number 1 executes SHM along x-axis as shown in the figure. Particle number 1 hands over the disturbance, part of that, to particle number 2. Particle 2 hands over this disturbance to particle number 3. There is a correction required, 3. disturbance reaches particle number 5, that is 3 to 4, 4 to 5, and at the end to E, ear. This is how wave travels from S to E parallel to x-axis. Time with you is 3 minutes. 3 minutes to write how sound travels from S to E, how particle number 1 gives information oscillation to 2, 2 gives this oscillation to 3, 3 to 4, 4 to 5, and 5 to E. B part deals with wavelength lambda, time period T, frequency F. You have already defined in 9th class, but we'll do it again. We'll do it for any wave, say transverse wave, number of particles. Yesterday we have covered in question number 1, particle number 1, 2, 3, 4, 5. This is how particle number 1 oscillates about its mean position. Particle number 2 will oscillate about mean position, 3, 4, 5. How much time it takes for this wave particle? T, capital T, which was, as an example, how much time? 4 seconds. The information travels from 1 to 2 in how much time? 1 second, 1 second, next 1 second, next 1 second. So, lambda is what? Wavelength. Is what? Distance covered by wave in how much time? Yes, distance covered by wave in time. Yes, in how much time? In time. Distance covered by wave in time, say T, 4 seconds. Wave covers this distance, 1 wavelength, lambda. If V is the speed, T is the time, lambda is equal to V into T. Distance covered by wave in time T. T is what time? Time taken by particle to complete one oscillation, where T is time taken by particle to complete one oscillation. This particle, this particle takes 1, 2, 3, 4, 4 seconds to complete one cycle. During this 4 seconds, this wave has covered some distance, this much. This is termed as wavelength lambda. T is what? Time taken by particle to complete one oscillation. Frequency, number of waves, number of cycles or waves per second. Relationship, F is equal to what? 1 by T. Time with you is 3 minutes. Define wavelength, time period, frequency.